A very good evening to everyone watching these assignment videos. I'm Ahmad Yusof and Ahmad Jasmin. Matches number 148428 will be presenting the study of LED effectiveness on plant growth for this course, solid state lighting. In today's research, we will discuss about the challenge faced of the LED towards plant in deep explanation within photosynthetic activity and to compile a lot of research with every benefit of each LED on each type of plants. By gathering 20 to 50 articles of data, the table of collective LEDs affecting each plant through different mixed spectrum. The risk gained throughout the research is some of the articles may be invalid or insufficiently informative from solid-state lighting. But in opposite, that will benefit gain will be informative for beginner farmer that focusing on life factor in agriculture through compensation for time and effort. In a passage of time, various empirical studies have been conducted and been gathered here to compile the effect of light-emitting diode to plant growth, which spectrum make the product of each plant grow effectively. Thus, this paper first discusses several phenomena of photosynthetic and photomorphogenic plant development from light source, introduction briefly to light-emitting diode, several experimentation using specific LED spectrum, and some application of light-emitting diode on plants. Photosynthesis is the basic process inside all plants. Photosynthetic bacteria and algae in which they use light source to synthesize organic molecules such as glucose, the source of energy need for all living things. The amount of energy needs for light reaction in photosynthesis process are ranged from 400 to 700 nanometer. Cytochromes and photoprene is sensitive to blue light because they are involved in several plant activities, including phototrophism, photomorphogenesis, stomata opening, and leaf photosynthetic activity. Meanwhile, phytochromes are red light sensitive, which used in photosynthetic activity. There are three phenomena happening in plant develops using light. The first is the process of capturing light. The second is process of photosynthesis in developing plant, and the other one is the plant reaction to light. Alright, common myth is that plants only capture or absorb red and blue light. The rest of the colors like green go unused. However, this graph shows that the wavelength of light that chlorophyll absorbs on the left, there's a peak in blue wavelength, and the right there another peak in red wavelength. In graph 1, shows that chlorophyll A abstract with its spectrum percent absorption and it absorbs a lot of red and blue light. However, in the middle, the green and yellow range, the red is significantly lower. So chlorophyll doesn't directly absorb much green and yellow light. There is also research did by Dr. Arnon where the chlorophyll experiment plant was liquefied as the leaf was blended and it was not in its natural state, which does have structure of or anatomy. The result is shown in graph 3, the below one. There is a comparison to the chlorophyll extract experiment for graph 3, where the structure is intact. The leaf absorbs a lot more green and yellow light. In figure 2, where spectrometer detects specific wavelength from a leaf, the results show red and blue light barely penetrates the top. However, green light illuminates the entire leaf chlorophyll. Since it absorbs red and blue light fully, the leaf blocks this light from penetrating deeper into the leaf and to any of the plant below. This is Matric curve. The Matric photosynthetically active radiation graph doesn't show absorbance. Instead, it shows the rate of photosynthesis by color. By measure the photosynthesis, it shows that plants use the full spectrum of light from 400 to 700 nanometers. However, the colors outside this range, such as infrared and ultraviolet color, also plays an important role in photosynthesis. Dr. Dr. McCree did this study by limiting his variables to set his experiment up to test each color individually, resulting shown in McCree power graph 4.2. In another research by Dr. Emerson, he used two different wavelengths at the same time to a plant. One in the red range and another one is in the infrared range. And what he found was that these two wavelengths together increases photosynthesis. It works when on any color of the light of the power range is combined with infrared. To explain this, first, photosystem 2 absorb light below 680 nanometers, which is red light, and use to split electrons from water and send it to the photosystem 1. The photosystem 1 then takes the electron and use light above 700 nanometers, which is infrared light, to increase photosynthesis. The whole process is called Emerson effect. The great example of how plants react to light is the amount of blue in the spectrum. Blue light is what plants use to sense whether they are in the shade, because blue light doesn't penetrate through plant canopy. So there is an optical amount of blue light in the spectrum for plant to grow the best, which is 23%. Plant reacts to red and blue grow light because there are a limited amount of green and infrared light that penetrate deep into the plant, resulting changes in length, area, and actions. For example, vegetative growth by react to infrared light by growing larger. Lastly, research indicates that infrared light increases certain antioxidants in plants that increase aroma and flavor. Throughout the history in solid-state lighting, the solid-state semiconductor diode, which is LEDs, is widely used as they have unique properties of emits photons that when current is applied. The p-type semiconductor known as anode when the current initially flow until it reaches n-type, which is known as cathode. The total energy loss of the electrons between p-n junction will be form of light energy or photons. The LED chips consist of light-emitting semiconductor material as well as lead frame with both cathode and anode onto which the dye is put. The latest generation LED is based on gallium aluminum arsenide semiconductor material built as a double heterostructure on a transparent substrate, and he has shown promise in plant growth and morphogenesis investigation. LED designers have also employed laser diodes with visible spectrum outputs to create high brightness LEDs. Modern blue LEDs are made of gallium nitride and silicon carbide and have a wide range of use, including telecommunication, message boards, and traffic control system. LED circuits can be built in a series or parallel configuration, but the amount of voltage is necessary for all the LEDs in the series circuits must be considered. Only the lowest appropriate enough voltage LED will generate light. In the case of many LED with varied voltage needs, and the excessive current flow through it may cause damage. When designing a parallel circuit, pay close attention to the amount of current necessary to travel through the LED, because each LED has a different forward voltage. Connecting them in series would be more complicated. If the voltage supplied by the source of electrical power is insufficient to excite the LED chip, the discrepancy will turn off part of the LEDs. High voltage, on the other hand, causes damage to the LED with a low forward voltage. Generally, LEDs used a series must have the same forward voltage or not different a lot for the circuit to function effectively. One of the most significant advantages of LED is the ability to adjust lighting spectra by picking specific of what needs, specifically relevant light wavelength and energy cost efficient to produce certain spectra such as green or yellow without other spectral. Hence, reduce the amount watts used as unwanted spectra are not produced, which they waste some of the electrical energy. Other than that, LEDs need less energy to deliver their effects and may be powered by batteries with low voltages. When compared to fluorescent light, LEDs produce very less heat. The issues that arise during cultivation conditions can greatly mitigate by adopting LEDs that produce very little heat. The most essential factor in lowering artificial farming expenses is using high photoelectric efficiency light source to provide light for photosynthesis and growth. The influence of LED on plant growth and development has recently piqued people's curiosity. Throughout these figures, or figure 6, red light did slightly affect overall psychological effect on plants, such as increase in size of leaf, fresh weight, shoot or root ratio, total phenolic content, and total anthocyanin content on plants. However, red light did decrease the stem length, shoot length, root length, and other that show in this slide. In opposite, blue light decrease the shoot length, root number, left area, root fresh, and etc. and etc. But excessive blue light will make the plant stunted as the shoot length and weight decrease a lot. The increase and maintain is shown in the slide. Okay. Green light has various psychological benefits such as supplementary red and blue LED with 510 to 530 nanometer red LED light. It also enhances lettuce growth. Increased leaf area in infrared light, it increased leaf area, and as a result, greater light interception was linked to lettuce growth enhancement under supplementary infrared spectrum. After an experiment done by using red and blue light with ratio 1:1, most of the result of each part of the plant grown well as seen in figure 8, the left side. Figure 8 shows that summary effect of red and blue light with ratio 1:1. One of the explanations for decreasing root length and dry weight figure would because of excessive blue light. Thus, this proves that 23 to 24% of blue light are enough for plant to grow healthier. From the table 2 shown below are the collective effect of LED on plant growth and their morphogenesis. As you can see that these are all type of plants with its application. So you may pause this slide to look for every plant needs as a new farmer. In conclusion, secondary metabolism and respiratory metabolism, which are strongly connected to agriculture product quality, should be investigated further or incorporated in future research of the influence of LED on plant growth and quality. That's all from me. Thank you.